Hey there, Seahawks, it's Miss Adams, and in this video, we're going to talk about transformation of quadratics. Alright, so there are four different kinds of transformations. There can be a vertical shift. Okay, so if it goes up, then your k units are going to increase. If it goes down, it's going to be minus k. Okay, so this is all based off of the parent function for a quadratic, which is just y equals x squared. Okay, so we're starting with x squared, and then we're adding stuff onto it. Okay, so if I add a k value, if it's positive, then my parabola moved up. If it's negative, then my parabola moved down. Horizontal shift, right and left. Okay, so inside of the parentheses where h would be. Okay, if it's a minus h, then it went to the right h units. If it says plus h, then it went to the left h units. Okay, so remember inside the parentheses, it's always kind of opposite of what you would think. So when you see a minus, it's really going to the right. And when you see a plus, it's really going to the left. That only is always inside the parentheses. Dilation, you can have a stretch or a compression. Okay, so if A is greater than 1, then it's going to be a stretch. It's going to be vertically stretched. It's going to be made taller. So when you make it taller, it's going to get skinnier. Okay, and then a compression, vertical shrink. It's going to shrink it down vertically, which means it's going to push it down. It's going to get fatter. Okay. And then a reflection, it can be reflected across the x-axis, which means it's going to take it from being positive to negative. Okay, so it's going to have a negative in front of the x squared, and that's going to flip it upside down. So you can kind of think of it that parabola is like a U shape. So if it's positive, it's like a smiley face, and if it's negative, it's like a frowny face. All right. Graph the parent function y equals x squared. All right, so y equals x squared. I'm going to go to 0, 0. And then you can create like a little table to get the other values. If I go to 1, 1 squared is 1. If I go to 2, 2 squared is 4. If I go to 3, 3 squared is 9. Okay, and then my vertex goes through right there in the y-axis, so I can do mirror image on the other side. And there's my parent function, y equals x squared. On the same graph a quadratic that was reflected over the x-axis, so that means it's going to be upside down, and shifted 3 units to the right. Okay, so it's going to be upside down. It's going to be shifted 3 units to the right. So I'm going to take my vertex, and I'm going to move it 3 units to the right, and then I'm going to go down. All right, write an equation from step 2. Okay, so if it was shifted 3 units to the right, then that means my h value changed, and if it was reflected, that means it's going to be a negative. So it's going to be y equals negative x, and then if I go to the right, it's going to be a minus 3 squared. And I didn't go up or down, so I don't have any k pieces to add. All right, on the same graph a quadratic that has a vertical stretch of 3 and was shifted left 1 unit and down 4 units. Okay, so I'm going to go left 1, down 4. That's my new vertex. And a vertical stretch of 3. So it was 1, 1. Now it's going to be, I'm going to go over 1, up 3. Then I went over 2, up 4. Now it's going to be over 2, up 12. And then I can't really fit that on there. So I'm just going to use those points. And if I wrote my equation, it would be y equals vertical stretch. So it's getting taller and thinner. That's a is greater than 1, so 3. And then x, I went left 1, so that's going to be a plus 1 squared. And then down 4, so that's going to be a minus 4. And then my parabola on that one, I didn't complete that. Gonna look something like that. Oh, there it was. All right, describe the transformation of f of x to g of x. So I went from f of x to g of x. Now, what happened? Okay, I can tell that it was reflected over the x-axis. Okay, so g of x was reflected over the x-axis, and then there was a compression. It was made fatter, so I shrunk it vertically, made it fatter, a compression of 1/4. Okay, so that one was at, we had a point at 2, 4, and then 4, -4. So where our 1, 1 was, we didn't have a matching like 1, 1 until we got to 4, -4, so that the compression was 1/4. You can kind of get it that way. So my function would be g of x equals negative, because it was reflected, and then it was a compression, so a is less than 1, 1/4 x squared. All right, describe the transformation from f of x to g of x. All right, so f of x is our parent function, and then g of x, it looks like it still went, like when I start my vertex, I went 1, 1, and then 2, 4. So it's still like it didn't compress or shrink or stretch or compress, but it just shifted. So it went to the right 2 and up 4. So it was translated right 2 units and up 4 units. Okay, so it would be g of x equals, a didn't do anything. So it's going to be x minus 2, because it went to the right 2 units. So that's a minus 2 squared. And then up 4, so k would be plus 4. And that's it.